Alright, so we are looking at 5.2 today. So this is page 6 in your packet. Just take a moment to read it yourself and try and understand the rules. Like I said before, most of these should be a review of Algebra 2 topics. So just take a quick look at it, read over it, and kind of familiarize yourself with the rules for exponents. All right. Alright, now you did that, we're going to flip over to page 7. We're going to do some problems here. I'm going to do a few of them, and then you can watch the video and follow along. Once I finish the video, I want you to go back and then do the rest of them on this page. Alright, I will key the whole page, so it'll be posted on Canvas in the daily agenda for you to see all the problems worked out. But for right now, I'm only going to do a select few, and then you can go back, try them, check your answers, and go from there. Alright. So, first things first, if I have the same bases being multiplied together, I add their exponents. Alright, so I'm going to get t to the 8 plus 4 plus negative 3. And hey, this variable does not have anything on it, so there's an exponent of 1. Alright, so t is t to the first, so this is going to be plus 1 in addition. So, that gives me t to the 8 plus 4 is 12, minus 3 is 9, plus 1 is 10. So this would be t to the 10th. Right. We're going to go ahead and flip over to number 4 here. All right. If I have negative exponents, I can move them across the fraction sign. All right. So just remember, even if it's not a fraction there, like say I had 2 to the negative third, I could rewrite that. I want to move it across the fraction sign. This is in technically the numerator. I could turn this into 1 over 2 to the third. So just as an understanding of that. You can move it across the fraction sign and you will make it positive, the exponent positive. So this becomes a to the 7th over a to the 3rd. Now, like over here, number 1, right? If you were multiplying, you add their exponents. So if you are dividing, you're going to subtract the exponents. So this is going to be a to the 7th minus 3, which is a to the 4th. Right. We're going to go ahead, jump down to number 7 here. So first things first, I got to deal with my order of operations. I have exponents here. I have this 2 on the outside, so I have to deal with that first. That 2 is going to get brought to each one of these terms. Now, I know we always make this mistake, and I tell you, don't break my heart the other day in math when you did it, but you have to understand the difference. If it is 2 plus x squared, all right, that is 2 plus x times 2 plus x, which would then have to be distributed as 4 plus 2x plus 2x plus x squared, okay? You can't just bring it down because there's an addition sign here. Since everything's being multiplied here, you can bring that exponent down. Alright? I'll show you a second way to kind of do this problem also, just so you're aware. So this would be 2 to the 2nd times w to the 4th raised to the 2nd. And I don't touch the denominator because there's no exponent on it. So now to simplify, 2 to the 2nd is just 4 times w to the 4th to the 2nd. If you have an exponent raised to an exponent, you multiply. So that would be w to the 8th all over 4w. Now, we just simplify our numbers. They always just behave the same way that numbers do. So 4 divided by 4 is just 1, so it'll cancel out. W to the 8th over w. Remember, if there's not an exponent, then it's always going to be to the first if there's a variable there. So this will be w to the 8th over w to the 1st. Since I am dividing, I subtract. So I get w to the 8th minus 1 to get me w to the 7th. Right. Another way to see this problem, if you don't like this rule because you always make this mistake, and another way you could do it is if you did 2w to the 4th squared over 4w. So, since we don't make the mistake, we're going to do exactly what squared means. Alright? 2w to the 4th times 2w to the 4th all over 4w. Alright, so now this is 2 times w to the 4th times 2 times w to the 4th. We know multiplication is commutative, so this could just be written as 2 times w to the 4th times w to the 4th, all over 4w. So now 2 times 2 is 4, w to the 4th times w to the 4th. I add their exponents, so it would be w to the 8th over 4w. And now we see we're in the same spot we were. We get w to the 8th over w, which is w to the 7th. So I would encourage you, sorry you can see the bottom of my work there, if you make this mistake here with 2 plus x or x plus 1 or whatever the case is, I would encourage you to just multiply this out so you don't make the mistake, or you can take the little shortcut and go from there. All right. Moving over to number 8 now. I got all the stuff in the middle raised to the 0 power. This is a very problem that can easily trip you up, which doesn't need to be. 2 ways you can do it. Anything, right, no matter how big or messy it is, raised to the 0 power is always just 1. So this is just actually going to equal 1. All right. Another way you can do it is you can distribute this 0 to everything like we just did in number 7. So this would be, hey, w to the 3 to the 0, x to the negative 7 to the 0, z to the 5th to the 0, all over w to the negative 11 to the 0, x to the 8 to the 0, z to the negative 2 to the 0. And now I multiply together, so right when I have w to the 3 to the 0, when I have exponent raised to the exponent, I multiply together. So that would be w to the 0, 3 times 0 is 0. I would have x to the 0, z to the 0, over w to the 0, x to the 0, z to the 0. Anything to the 0 power is 1, so w to the 0 is 1 times 1 times 1 over 1 times 1 times 1, which is just 1. So same answer if you didn't see that trick and you needed to go all the way through. All right. Next one we're going to look at is number 10. So I'm just going to start, hey, if they have the same exponent, the same base, I can combine them. So x to the 1/2 times x to the 1/4, I can combine them. That's going to be, I'm going to add them together. So it's going to be x to the 1/2 plus 1/4 over x to the 1/12. 1/2 plus 1/4, well, you just, you need common denominators, so I'm going to multiply this by 2 over 2. So it's really x to the 2 over 4, or I get x to the 3/4 over x to the 1/12. All right. And now since I'm dividing, all right, I am going to subtract their exponents. So I have x to the 3/4 minus 1/12. But again, I need common denominator, so I need to multiply this fraction by 3 over 3. So this is going to be x to the 9 over 12 minus 1 over 12, which would be x to the 8 over 12. 8 over 12 as a fraction can get simplified. It becomes, they both can be divisible by 4. So this is going to be 2/3, x to the 2/3. Right. If you wanted to do a little practice with your rational exponents, all right, remember this can get switched over into a radical for us. The base number, the denominator of the fraction, becomes our root. The numerator becomes our power. So this would also be the cubed root of x squared is another way you could write this as your answer. All right. And look at that. That's a nice little lead-in to number 12 for us. All right, 81 to the 3/4, exactly what we're going to do. We're going to rewrite this as a radical. So the denominator becomes my base. The 4th root of what was my base stays inside, and then my numerator becomes the exponent to the 3rd. All right. You could also rewrite this as the 4th root of 81, and then quantity cubed. You could bring that cube out. All right. So from here, I'm going to take my 81. I'm going to break it down is broken down to 9 times 9, and I'll break those down to 3 times 3, 3 times 3. All right. And now, I'm looking for a group in the size of my radical. So my radical is 4, so I need a group of size 4. So I have 1 3, 2 3s, 3 3s, and 4 3s. Since I have a group of 4, which is equal to my base, or my radical, all right, I can pull this out, and I pull it out as one single group of 3. All right? And then I have nothing left over. At best, I would have a one left over, so you could write this as like 4 root. Okay. The fourth root of 1, just to visualize, I pulled all that 81 out, but the fourth root of 1 is just going to be 1, so this really is just 3. So the fourth root of 81 is 3. This will then get cubed from the outside to be 27. All right. I'm going to go ahead, look over 13. There's a couple ways you can do this. We're just going to stick to our rules. I think the more we stick to them and the more we iron those out, the better we'll be. So I'm going to bring this down to both things. So this is going to be 9 to the negative 3 halves over 4 to the negative 3 halves. Alright, I can go across the denominator, or the fraction sign, and make it a positive. So this is 4 to the 3 halves over 9 to the 3 halves. And now I have some radicals I could deal with. So my denominator is 2, so that becomes my root. So 2 root 4 to the third over 2 root 9 to the third. All right. This can get pulled out. 2 root 4 to the third over 2 root 9 to the third. The second root is just the square root, right? So the square root of 4 is just 2. Over the square root of 9 is just 3. So this is now 2 cubed, which is 8, over 3 cubed, which is 27. And that is my final answer. All right. So those are just simplifying expressions, right? Nothing with equal signs, so it's just solving or simplifying expressions. And we're going to take a look here at 3 kind of equation-based problems. All right. So number 14, 2 to the 2x minus 1 equals 4. So I'm going to, the first thing you have to do, you always have to have common bases. All right. The same way you need common denominators to simplify fractions.